All right, when you're asked to factor a polynomial such as this, there are 4 different terms here. You can always look at it and see if there's something that you can factor out of each of these terms, something that you can divide each of these terms by. For instance, if they all have an x, you can factor out an x. Or if you can divide them all by 2, you could factor out a 2. But in this case, I don't see anything that they have in common. So what you want to do is start to look at maybe 2 at a time. And for instance, if I look at these 2 terms, 7 and 21, is there anything I can factor out? Yeah, I can divide them both by 7. Or, excuse me, these 2 terms, 5 and 15, is there anything I can factor out of those? Yeah, I can divide them both by 5. So in this case, the first step in something like this is to kind of group together the terms and see if you notice you can factor something out of a small group of it that maybe you can't factor out of everything. And in this case, it's convenient because they're right next to each other. That's not always going to be the case. For instance, say this was written like this. The commutative property allows you to move these terms around. So you could change this to this up here. I could have moved the 7 and the 21 to be next to each other and the 5 and the 15 to be next to each other. So in this case, though, they're already kind of grouped, the left and the right sides. So I'm just going to look at one side at a time. So let's put over here 7x to the third minus 21x squared. Now, when you're factoring out the greatest common factor, you might not need to go through the steps I'm going to show you here. You might just be able to see, okay, I can factor out a 3. Oh, I can factor out an x squared. What's left? And put that in parentheses. I'm just showing you some steps if it is not as clear as that for you. So what I like to do is look at the coefficients first. So I have a 7. And I have a 21. And I first say, what can I divide 7 and 21 both by? And I can divide them both by 3. So I'm just going to write that down here and say, well, oh, sorry, I can't divide them both by 3. My goodness, I can divide them both by 7. So when I write that down here, 7 divided by 7 cancels out, so I'm just left with x to the third. 21 divided by 7, or negative 21 divided by 7 is negative 3, x to the second. So far, I've factored out a 7, and this is what I have left. Now I'm going to ask myself, well, what can I factor out of the x's? I start looking at the variables. In this case, there's just one, x's. So x to the third and x squared. What do they have in common? What's the most x's that they both have? They don't both have x to the third, but they do both have at least 2 x's multiplied together. So what I'm going to factor out is an x squared. You're looking for the greatest common factor. And remember, when you're dividing exponents, what do you do with the exponents? You subtract them. So x to the third divided by x squared is just x to the first, or x. And then on the right, x squared divided by x squared, any number divided by itself, whether it's x squared divided by x squared, that equals 1, or if it's 8 divided by 8, that equals 1. Anything divided by itself is 1. It cancels out. So we're just left with minus 3. And then you can look at it and say, is there anything I can divide x by that I can divide 3 by? Nothing besides 1, and that's not going to change it at all. So what we have done so far is we have divided by 7, and we have divided by x squared. And what we have left is x minus 3. So we have factored that side. Now let's look at the part on the right, the two terms on the right. We have a positive 5x minus 15. So again, I always look at the coefficients and say, okay, 5 minus 15. What can I divide them both by? I can divide them both by 5. When I do that, I'm left with x minus 3. And then again, x minus 3, I can't divide x by something and 3 by something except for 1. They don't have any other common factors that's going to change it at all. So for this one, the only thing we were able to factor out, divide by, was a positive 5, and what we are left with is x minus 3. So you group the two sides, and then you factor out the greatest common factor of each, and then you look at what you have left. So I'm just going to write it down in one big long statement. So we have 7x squared, x minus 3, plus 5x minus 3. So the last step is to look at the terms you have left. When you're factoring, you're looking at each term and saying, what can I factor out from each of these terms that they have in common? So remember, terms are separated by a plus or minus sign. So here, even though it's long and messy here and here, those are each terms. So we're looking at this term on the left and this term on the right and saying, what do they have in common? Right, you see they are both being multiplied by x minus 3. So we can divide this side by x minus 3 or factor out an x minus 3. And we can divide this side by x minus 3 or factor out an x minus 3. And remember, anything divided by itself is just 1. X minus 3 divided by x minus 3 is 1. So this cancels out and this cancels out. So what we are left with, we factored out an x minus 3 and we're left with 7x squared plus 5. 7x squared plus 5. So this was our original polynomial, and what we've done is change it to this multiplication problem. We've changed it to groupings of factors.